Welcome to NextGen Manufacturing Nexus. Today, we're diving deep to meet the people who are building the future of, well, everything, from medicine to food to energy. We're talking about the biochemical engineers. Let's jump right in. Okay, take a look at this. You might just see a vial of medicine, right? Maybe something super advanced like an mRNA vaccine. But what you're really looking at is a tiny miracle, the final product of a massively complex, high-stakes manufacturing process. And that, right there, is the billion-dollar question. I mean, it's one thing to have a breakthrough in a lab. It's a completely different universe to figure out how to produce it safely, affordably, and for millions of people around the globe. And that leads us straight to our first big idea, the billion-dollar bottleneck. See, the challenge of scaling up has created this huge pinch point in modern industry. We're in a whole new era of medicine, but our ability to actually make this stuff is struggling to keep up. Just look at the pressure on the system. We need more kinds of drugs for more people all over the world, and we need them produced faster with higher quality than ever before, and here's the kicker, at a lower cost. It's a classic, massive industrial scaling problem. And here's what it all boils down to. The real bottleneck isn't the science in the lab anymore. The problem is in the factory. It's an engineering problem, and it takes a very specific kind of problem solver to tackle it. Which brings us to the hero of our story. We're talking about the person who bridges that enormous gap between a discovery in a petri dish and a life-saving treatment that can reach the entire planet. And that person is the biochemical engineer. Their whole job is right there in the definition. They are the ultimate translators. They take these delicate, small-scale scientific finds and figure out how to make them work on a massive industrial scale, day in and day out. And their impact is just huge. We're not just talking about pills and vaccines. Biochemical engineers are the key players behind biofuels, the way our food is made, all kinds of biotechnology, and even making sure we have clean water. They are absolutely fundamental to our modern world. So, what's in the toolkit for one of these industrial translators? Well, it's this really cool mix of deep knowledge, a specific kind of mindset, and some serious hands-on skills. Okay, first, the foundation is all about knowledge. You've got to have the core engineering and science down cold, of course, but you also have to be a master of process safety and navigate these super complex world of regulations. Then, on top of that, you need the right mindset. You've got to be obsessed with quality. That's totally non-negotiable. But you also have to be a great communicator, someone who can explain complex stuff to all kinds of different teams, and crucially, adapt on the fly when things don't go according to plan. And this is where it all comes together. It's a constant problem-solving loop. You start by analyzing tons of data from high-tech systems that give you a bird's-eye view. But then you got to get your boots on the ground, physically inspect the equipment, and talk to the operators and scientists on the floor. It's that blend of big data and human experience that lets you find and implement those creative, real-time solutions. And make no mistake, these engineers aren't just babysitting old systems. They're right at the forefront, leading a revolution in how we make things. Just look at this shift. The old way? These enormous, permanent stainless steel tanks. They were workhorses, for sure, but super inflexible and took forever to clean between batches. The new way? Modular, single-use systems. Think of them like high-tech, sterile, disposable bags that give you incredible flexibility and let you switch from one product to another in no time. But here's the really smart part. It's not about just throwing out the old stuff. The real engineering genius is in creating a hybrid approach, mixing these new, agile technologies with the old, reliable facilities to get the best of both worlds. All of this evolution is pushing the entire industry into a new frontier. It's a massive technological upgrade we call Industry 4.0. So, what's the end goal here? What's the holy grail that all this technology and brainpower is chasing? It's this continuous manufacturing. You know, forget making things in separate, clunky batches. The dream is a smooth, non-stop flow, from raw materials coming in one end to the finished product going out the other, all watched over in real time by smart AI and digital tools. It sounds futuristic, but it's actually how almost every other major industry has worked for decades. And the payoff is enormous. We're talking huge cost reductions, smaller factories, using our plants way more efficiently, and checking quality every single second. This isn't just about saving a few bucks. This is how we make the next wave of amazing medicines affordable for everyone. So here's the bottom line. This quote really nails it. The industry has the amazing science down. What it desperately needs now are talented engineers to bring in these proven, super efficient manufacturing ideas from other sectors and make them work for biology. The biochemical engineer, they're standing right at that crossroads of biology, data, and heavy machinery. They're not just running factories, they're designing and building the very engines of modern life. They're the ones turning scientific miracles into global realities. The only question is, who's ready to build the future with them?